Here's an example of the steam engine. Here's the valve connecting rod that you're going to be making. Okay, what we want to do is we want to take this stock and turn it into this valve connecting rod here. And what I've got here is a fixture I've designed and made to hold the stock. This goes right in the vise, or it can be clamped to the table. And you can see this fixture. What we do is we slide the stock in here, and it locates against these two pins, and then this pin, and then you throw the handle, and these two pins come down and clamp the stock. Then we run the program. It bores out this hole, drills a hole here, and we're able to put this little plug in here, a screw in on this end. That holds it in place while the outer profile gets machined. Once the outer profile is machined, the part's done. We can take it out, deburr it, and run the next part. You can take a little closer look at the fixture maybe. See the fixture is designed, a very typical fixture design is you use a 3-2-1 means of locating your part. The 3 actually represents the plane here. There can be 3 pins. In this case I just used the plane. And then 2 more pins to locate it. And then the last pin there. 3-2-1 locates a part in space. So if I take this part and put it on 3 points, I've located it in that plane, but it can slide all around. Now if I slide it up against 2 more pins, I've located that part, but it still has this degree of freedom, if you will, to slide around. It only takes 1 pin now to locate that. So that's something you would learn if you were designing fixtures. And then this handle simply pulls up on this screw, which goes underneath. That screw pulls on this plate, which pivots right here. And so when this goes up, when the handle is pulled, tightened, this goes down. And these 2 pins, clamping pins, are pinned to this plate and allowed to pivot. So I don't know if you can see them going up and down at this point, but that's how that fixture works. This is a setup document. This is something that might be written by the manufacturing engineer and or the programmer, and it communicates to the setup person, the person that's going to be setting up the machine, all the information they need to know. For instance, they need to know what tooling. So tool 1 is a number 4 center drill, and it tells you your height offset and diameter offsets if there are any. And tool 2 is a number 29 drill. Tool 3 is a 3/8 end mill. And then again we're going to have tool 3 here as a 3/8 end mill. For the second setup. See, this is setup 1 and setup 2. Now, I haven't done this for a while, so having this setup document is going to help me a lot, because this tells me other things. Like it tells me I've got some sketches and things, but it tells me how to mount the fixture. It tells me where to put the program reference 0, which is the 0 of the coordinate system. It says, per the drawing attached, so look at those drawings, load the stock into the fixture, and then load T1, run the program, load T2, run the program, load T3, run the program. So this allows the setup person to set up the machine and make the first part or two. And if we look at that next page, here's a drawing of the fixture, which I showed you earlier, and it shows you the top of the fixture, and it shows you where the program reference 0 is, the PRZ. So that's the 0, 0 of the XY, the Cartesian coordinate system. And then we also need to know where the Z0 is in the, where 0 is in the Z direction, and that's showing it at the top of the fixture. That's important to know, because if I thought it was at the top of the part, then it wouldn't be machining the part at all. If I thought it was below the fixture, then it might actually crash. So it shows that. And then here we also see a printout of the 2 setups from SurfCam. We see the stock loaded for setup 1. And here we see the stock loaded in setup 2 with the plug and the screw in place. So that's a setup document. You got to remember that you're writing it for someone else that knows absolutely nothing about the process, and so it's very important to communicate all that information. This is the CNC milling machine we're going to be using. It's a vertical milling machine. It's very similar to the Bridgeports you've seen, and it has the same axes, X, Y, and Z axis. It's got the vertical axis here. The spindle axis on the mill is always the Z axis, and the next longest axis is always the X, and the axis at a right angle to those two is then the Y axis. The only difference is, instead of controlling it by hand with hand wheels, now we have these little motors, and a computer and a control that controls the movement using a program. Turn the machine on, you turn the switch on the side, assuming the main power is on the wall over there. Once that's on, you need to turn the emergency stop clockwise. Don't just try pulling it out, you've got to give it a twist. The computer will boot up. Takes about a minute. Transfer files back and forth from this. We do have a USB port on the side of this control, so we can get right in and transfer files to it right from SurfCam or whatever software you're using. Once this is completely booted up, we're going to have to send the machine home. Now, when the machine is turned on, it doesn't really know where it is. You have to send it home. The machine goes to its extreme limits, hits a limit switch, and it lets the machine, the control, know where it is. So once that comes up, we'll do that. And on this panel, we'll be going over some of these buttons a little bit, but one of the things we can show you first here is the feed rate override knob. This feed rate override knob, if we turn it to on 100%, the program says to go 5 inches a minute, it'll go 5 inches a minute. If we have it on 50%, it'll go 2.5 inches a minute, and so forth. And you can override too in the plus range. Go up to, I'm not sure what the amount is, I think it's 120%, 120% right there. Now I'm going to hit the cycle start button, this green button, to send it to its home position. I'm going to make sure everything is clear before I do that. I don't want to stand around it. I don't want the vice handle on here because the vice handle can get caught, so I'm going to take that vice handle off. Go ahead and hit cycle start. You'll see that it's going to move all the way to the extreme limit of the X. It's going to hit this strip switch. It's going to hit it and back off a little bit. When you hit that cycle start, it's just running a little macro program in here. It's sending it to its home position in the X and its home position in the Y. Now it's coming in the Y direction. Give you an opportunity to see the different axes here. So the cooling nozzle. Not overly exciting, but this is something you have to do every time you turn the machine on. Some machines won't let you go any further until you do. Others will let you do it, but then you might run into a really crazy error later on if you don't. So once it goes off the X, it checks the Y axis, Z axis, which is already done, and then it goes and it checks the fourth axis, which is the rotational axis. Okay, so now you can see that the screen has come up, and we're going to be able to move the table around manually. Moving around manually, I'm going to go ahead and look at this panel right here. It's axis motion controls. And first thing I'm going to do is I'm going to go into MPG, which is a manual pulse generator. Not main potato growers, manual pulse generator. Then we're going to go from incremental to continuous. So the light is off, so I know we're continuous. And now if I push these axes, it's going to move in the plus or minus direction of the axis. So I want to go in the minus X direction. You can see the table moving now. Then the minus Y. See if I can move that table around. And we also have the handheld manual pulse generator. Handheld manual pulse generator. I can snap to whatever axis I want to move, X, Y, or Z, or my fourth rotational axis. And while I'm in that, I can rotate this wheel. Now I'm going in a negative X, now I'm going in a positive X. Maybe see this handle moving. I don't know if you can see the handle moving as I'm doing that. It moves pretty slowly, but this is used when you want to get in and position the tool to its final location. And also in the control panel here, we can switch between slow movement. So now if I push on the axis, you see it moves pretty slowly. If I go to fast, rabbit, and I push it, it goes a little bit faster. You want to be careful with that fast position, rapid traversing, not to crash the car. Okay, I'm going to load the fixture, and again you go to your setup sheet, make sure you have the right fixture, and then you want to load it so it's going in the right direction. So the setup sheet tells me all of that. There's some parallels in there. I'll load my fixture in, tighten the vise. When you tighten the vise, you always want to tighten in a down position. And I might just give it a few taps with the dead below hammer just to make sure it's sufficiently held in place here. sufficiently located. Next I have to locate my program reference serial. So what I'm trying to do is I'll take the whole coordinate system of the machine and I want to shift it to that PRZ point. And my setup sheet said it's going to be the center of this hole. In fact, that hole is there for two reasons. One, it gives me a diameter to indicate from, so I can find my X and Y zero position. It also relieves the hole that gets bored here so that this tapped hole for the plug doesn't get damaged when it's being machined. So threads don't get damaged, so we can make hundreds of parts all day long without having to worry about that. Okay, so next I'm going to put my indicator up inside my spindle. Now, here we have a National Milling Machine taper, 3.5 inches a foot. And you also have these little slots here. These line up with lugs inside of the spindle. And we also have the threaded end for the drawing bar. There's a pneumatic drawing bar in this machine. The lugs inside the spindle line up with the lugs outside the spindle. So I'm going to put this up in and hold it in place. I'll give you a second to reposition the camera probably. Up here we have a control valve to control the pneumatic drawing bar. And on this side you have to push in on the green button in order for this in or out to work. It's going to be kind of loud. I'm going to push in on that and I'm going to hold in the in button. Make sure those lugs are lined up here. Make sure it's engaged before I continue. And then once the tone of that drawing bar becomes constant, you know it's as tight as it's going to get. And I'm going to have it always give it a little spin to make sure it is in there straight. And you see I've got a dial test indicator mounted here. Show you that in other demonstrations. So now I'm going to locate my spindle axis right over that counterboard hole. So, just like I showed you before, positioning the table using these axis motion controls, I'm going to go ahead and move the negative X. Now if you notice, when I push the negative X button, the table goes to the right. Now, positive X is to the right, but it's relative to the tool movement. Or negative X is when this tool goes to the left of the part. In order for that to happen, the table is what's moving, so the table has to move to the right in order for that to happen. So as you see here, the table goes to the right relative to the tool, it's going to the left. So all moves in CNC are made relative to the tool. Alright, so let's go ahead and try to position our indicator right over that hole. Take just a minute. So here's where I'll take my handheld manual pulse generator here. Put the indicator down, get some wobble in it. Down on the Z. You can see how handy it is to be able to have this right next to you while you're setting up your workpiece. Y position. It's looking pretty good. We have to eyeball it pretty close first to get within the range of the indicator. This indicator has a fairly small range, so we have to be pretty close before we can actually make contact with the piece. Alright, now let's get it somewhere in the ballpark in the X direction. That's not too bad. And I'm not going to be able to see all of this, but what I'll do is I'll zero it in the back, because I've shown you all how to do that before. So I'm going to go ahead and bring the indicator down into the hole, and I'm zeroing the bezel on the indicator. And now I'm going to rotate it around to the front. Now, you can see now that the indicator, as I've gone from the front to the back, it's gone counterclockwise about 7, so I'm just going to go ahead and split that difference about 3.5. Now, on this axis motion control, I can change what each click on the pulse generates. So right now, every click is moving 1/1000th of an inch. I can come down here and make every click move 1/10,000th of an inch. In fact, on the screen, you can see if I turn this one click, it changes 1/10,000th of an inch. 1/10 as the machinist would say. If I change the multiplier there, I can change it to 1/1000th of an inch per click. So again, using my setup sheet, I'm setting up my tools here. I know that tool 1 is a number 4 center drill. I put in this drill chuck right here. And tool's number 29 drill. And tool 3 is a 3/8 end mill. I've got a center cutting carbide end mill here. And this is another type of tool holder that you probably haven't used yet. It's just got a hole in it. Slide your end mill in. Notice the flat on that shank. It's called a Weldon style shank when it has a flat like that. Just slide it right in and tighten that set screw right down. It wants to be good and snug. And I like to position my tools in the order they're going to be used. So tool 1, tool 2, tool 3. When you don't have an automatic tool changer, it works out nice that way for me. I'm not confused. And I just double check with my setup sheet, and yep, it matches right up. So now what you want to do on this machine is you want to load your longest tool. So I'm going to take my drill bit and load that right in. If you notice, all of these tools are different heights. So when I tell each of these tools to go to a particular coordinate and come down to Z0, there's going to have to be a height offset there. And each of these tools, when this goes to Z0, it's going to be fine. When this goes to Z0, it's going to think that it's longer unless there's a height offset there. So it needs to know the difference from the longest tool to the next tool, and from the longest tool to this tool, so that when it picks up a new tool, it automatically compensates for that extra height. So next we'll go ahead and load our longest tool in the machine. Okay, so we position the spindle axis over that hole where our PRZ is going to be. If you notice now, the screen does not say X0, Y0 like we want it to. So what I'm going to do is I'm going to change those coordinates, shift the whole coordinate system to 0, 0 there. So there are a number of ways to do that. One way I like to do it is to just go ahead and hit MDI. Now MDI stands for Manual Data Input. I'm going to hit F3, and it jumps me into a screen that allows me to type in one block of information, hit cycle start, and it executes that one block. It doesn't store it, it doesn't remember it, it just executes that one block. And if I give this a G92 X0 Y0. Now that's called a block in programming, and we'll get into this more later on. A block consists of words, and each word is a letter followed by numbers. In this case, it's G92, that's telling it where you currently are. The following information is going to be where you're at. So I'm going to shift the coordinates. So when I hit cycle start now, cycle start, you should see these numbers change to X0, Y0. See we changed to X0, Y0. The machine didn't move at all. We have our spindle axis over our PRZ, and now our screen reads 0, 0 over our PRZ. So we've set up our PRZ right there. Okay. Now before you install any tooling, you always want to make sure that that taper is nice and clean. We don't want any chips on there, or the spindle's going to wobble and quite damage the inside of the spindle. Once again, I'm going to put that up in, and remember, I always got to spin my hand, make sure that's not wobbling. And next what I need to do is need to tell the machine where the end of that tool is, where that Z0 position is going to be. And so I'm going to go ahead and jog the machine down a bit. And once again, my setup sheet tells me where my Z0 is going to be. Actually, in setting up the tool length offset, you can use any height offset. You can use any reference surface that you want. I like to use just a 10 thousandths feeler gauge here, or a piece of paper works pretty well too. But I'm going to go ahead and lower that part down, lower that drill down, so I just touch that feeler. I'm going to use that same spot to touch off for all the tools. When I start getting closer, I'm going to go to a finer increment, so each click is 1/10 of an inch, 1/10 thousandths. And that just rubs, which is right about, turn around, this part there, right? Turn around, right about there. is actually holding up on that a little bit. There it is. See, it starts to drag, so I want to feel how much drag there is there, and now I can start setting up my machine. We look at the monitor again here. One thing I like about this control is if you don't see what you want, just hit escape until you do. So I'm going to hit escape, and now I can get into setup. Setup is F1, and I'm going to set up the tool. F2. Go to my offset library. And here we have the offset library, and we're going to set up the length of this tool. So here where it says Z reference, push Z reference F1, and it will tell you what to do. It says load the reference tool, which in this case is going to be the longest tool, and jog to the reference position. So we've done that. We've jogged to the reference position using that little feeler, and press F10 to save that reference. So I'm going to press F10 to save it, and it says, oh, you got to be on the right tool first though. That is tool 2. Let's repeat that. No extra charge, extra teaching here. Let's see. Load the reference tool, draw the reference position, press F10. Hit F10. You gotta make sure you're on the tool that's currently installed in the spindle when you do that. If that doesn't go to 0, just hit measure there, F2. Hit it at 0. Okay, while we're at it, while we're right here, while you can see this monitor, I'm gonna go ahead and set up my diameter offset. Again, I go to my setup sheet, and for the number 4 center drill, the diameter drills don't need any diameter offset. So that can be 0. For the other drill, there is no offset there. And for the end mill, I have written down here 373. This is a pretty good amount. Just type in the amount, hit enter, and we've got the diameter offsets set up. Now when you write a program, the program causes the center of the spindle axis to follow the outline of the part. Well, if you put a cutter in, you're going to undersize your part. So cutter compensation allows the cutter to be moved by the radius that's in this amount. So as the program's running, the program's going to see a D3 in there. When it sees a D3, it tells the control to move the radius of the cutter away from the part and go around the machine right. We'll talk about that more over here too. So that's the diameter offset. So we've got our longest tool in, we've hit measure. We've got the rest of the tools in and measure the difference between those heights. So I'm going to go ahead and remove this tool. Oops, bring it up first. Go ahead and put tool 1 in. Tool 1 is the center drill. Put it in there. Give it a spin. Looks okay. Okay, so we're going to touch off on that same reference surface. Lower this down a little closer here. Piece of paper sometimes works a lot better if you're using carbide tools because carbide chips very easily, but I should be able to get this pretty accurately. It's dragging right there. So now going back to the monitor, we want to scroll over to our height offset for tool number 1. That's why it's so important to have that setup sheet. We know that this is tool number 1. Going to the height offset 1, I'm going to hit measure. What that's going to do is it's going to measure the difference in height between the longest reference tool, which is the first tool we put in, and where it currently is. So I hit measure here, F2, and you'll see that value should change. So it changes to the difference in height between those two tools. Notice it's a negative too. That's why I always do it from the longest tool. That way if something goes wrong, hopefully the tool will come down and it will be far away from the part as opposed to coming down and being far through the part by mistake. So that's why I always have the longest tool be the reference tool, and that's how they're showing it here too. Then you just repeat that process for the remaining tools, and we only have one more tool to do. So I'm going to go ahead and bring up the spindle, take that tool out, take the next tool, which is also the shortest tool. And the other thing that can go wrong here is if your shortest tool doesn't actually reach, you have to repeat this whole process. before you start this process, you should just load the shortest tool and make sure it's going to come all the way down. And this is a good place to be paying attention and not talking too short. Don't ram that cutter right into the fixture. And down to it's kind of close. This is carbide, so we have to be a little careful not to chip it. Usually when I say something like that, I turn it around and chip it. Okay, now I'm going to slow that down to tenths. I want to go until it just starts to drag. I'm not going to rush this one at all. And once that's there, we can go ahead and hit measure again. There it is, right there. Go back up to the screen. You got to make sure you're on the right tool. So again, tool number 3 is my 3/8 MO. I look at my setup sheet, come down to tool 3, I hit measure, F2, measure. If you notice, I'm hitting F2 on the keyboard as opposed to these soft keys up here. These don't work. We have to use the keyboard. So that measures the difference between the offset from the longest tool to here. Now, don't forget to hit save here. If you get to hit save here, you've lost everything. So I'm going to hit F10, save. That's done. And while we're right here, let's go into the tool library. The tool library. Now this is just to give a message to the operator. The operator is the person running the part all the time, making parts. So I'm going to come over to here, and tool 1 is actually a center drill. And I picked this in earlier. Tool 2 is a .136 drill. And tool 3 is a .375 end mill. So in the program, as the program is running, when it says tool 3, 1.375 end mill will actually show on the screen. And it's kind of a verification that you have the right tool in there. But the machine doesn't actually read this, it doesn't know what this says. Okay, so that's good. I'm going to hit save. Again, I don't see what I want, so I'm just going to keep hitting escape until I do. Now we have one more thing left to do. The machine knows the difference in heights between the different tools, but it doesn't know where Z0 is for any of the tools. So right now you see I've got tool 3 is in there, and it thinks it's at minus 0.5921. Well, my setup sheet says the top of this fixture is Z0, and I've got a 10,000 feeler here, so technically I'm at Z10,000s right now. So we've got to be able to change that. And the best way to do this in this machine is to go to setup, part, and here you see we can use an edge finder. In this case we used an indicator. We can use an edge finder, or I can go F1 to the next axis, edge finder in the front or back. You can also change the position. I'll show you how to do that. Change the approach from. You can approach from the front, approach from the center, approach from the back. But we've done the X and the Y's already, so I'm going to go ahead and go to the next axis, which is the Z axis. And so we're going to bring down our tool number. We have to know what tool it is to some position that we know, and we're going to type that position in. So right now we are at, like I said, Z10,000. So I'm going to go Z 10,000, 0.01, enter. And it has to know what tool number we're on, because remember the tools are different lengths. So I'm going to go to, this is tool number 3, so I'm going to type in 3 here, and hit enter. 10,000s, tool number 3, that is at 10,000s. So now you see this hasn't changed yet. Z value. As soon as I hit F10 set, you should see that change to Z10,000s. And you should see that on the monitor here, it says tool, we got tool 3 in, and H3 means it's at height offset for tool 3. So it's verifying that for tool 3, height offset 3, we're at Z10,000s. Hopefully that helps clarify tool length offsets. So I'm going to bring that spindle up. And I have to put my first tool in. Go ahead and take that tool out. Tool 1, according to the setup sheet, again, is the center drill. Some CNC machines have automatic tool changers, so the operator doesn't have to do anything, it just automatically changes the tools. my little shim here, and I've got some stock. I'll cut. I'm going to take some of the stock, pack a piece of it. So I'm going to take my stock, it's all been cut, all deburred, all cleaned up. The one nice thing about this fixture in this program is you don't have to actually mill the ends. As long as you're getting a fairly square saw cut, there's enough material removed on the ends so that you don't have to worry about it. I put my part in on my fixture, that's my three points. Then I'm going to slide it through the clamps, up against the 2 pins in the back, and then up against the 1 pin over here. 3, 2, 1, we've located the part. We hold it firmly in that direction, and then we go ahead and lock the handle. Whoop. And what I just launched is what we hope to end up with when we're all done. So next, I want to position my coolant where my drill is going to be. The drill doesn't move in the X and Y relative to the coolant, so I can position it, but it is going to come down. Next thing I want to do is make sure I have the right program loaded, which I don't, so I'm going to have to go ahead and take a look at the monitor and show you how to do that. On the setup sheet, it should say what program to use. It should say what fixture to use, what program to use, what stock to use, all that stuff. So, don't see what I want, I'm going to hit escape. Still don't see what I want, I'm going to hit escape. So I see load, that's what I want, so I hit F2, load, and I have previously loaded this onto the hard drive from a pin drive, and I believe it's called. So I continue to scroll over until I find the valve connecting rod program, and I just go ahead and hit F10 accept. I want to verify that it says valve connecting rod, and I'm also going to graph this before I run the part. There are a number of ways to verify it before you actually start cutting chips. One is to go ahead and graph it on here, another is in your surf cam operation. Another thing you can do is you can lower the table down several inches and run the program, dry run it so it doesn't actually cut anything. Cut in and wax, as we talked about. There's a number of ways of doing it, but you want to at least graph it. Now go ahead and graph it, and I can see here that this yellow is showing me the center of the tool, and the gray is showing me what's left after the tool cuts the stock. So you can see that there's a double line here. It cuts around and roughs it, and it goes around and takes a finished cut, and then it comes in the middle, and it roughs it, and then it goes ahead and takes a finished cut. Now the reason that is offset, that amount, is that's the cutter compensation. In the program, it went and looked for that cutter, and it offset by the radius of that cutter in order to go around. And the program actually, follows the profile of the part, the cutter comp offsets. All right, that looks good. We don't have any errors there. It doesn't say any axis over travel or anything like that. If it did, we could go into edit here, F6. And you can see the code. We'll get into the code more later on, which is just called a code written in word address format, G code. Everybody just calls it G code. You have sequence numbers. And one thing I will point out in the code, you notice here that in parentheses, anything in parentheses this machine ignores. I put a bunch of stuff in here, like I put my name, what the program is, where the PRZ is, what tools are used, how to set up the fixture. All that is there again, so that if I look at this 10 years from now, I don't just look at a bunch of alphanumeric junk, but I have some idea of what it is. It's a good habit to get into. Also, I've annotated so that here it says number 29, drill, 1 hole. Here it says 3/8 2 fluid end mill, contour the big hole. So if going through the program, I know what's there. Anyway, that's an example of a program. We'll get into that more later too. I believe it's Alt F. Get out of here. Exit. So that looks good. First time you run a program after a setup, it's also a good idea to turn your feed rate override all the way down. You hit cycle start, and you just kind of creep it up from there. Okay, you can see I've positioned some shields around here because the coolant and chips are going to be flying. A lot of CNC machines are entirely enclosed while they're running. This one isn't, which in a way is kind of good for us to be able to see. I can swing this up and down, and you should always take the handle off the vise, because as the table's moving back and forth, the handle might tip the table and cause the vise to swivel right in the middle of the cut. So I've turned my feed rate down. I should be able to just go ahead and hit cycle start here. It's start the program. Hit cycle start, and gets to the beginning of the program, you're going to hit cycle start again. See, it's so comforting to look on my program and see valve connecting rod program. It helps. And we'll hit cycle start again. And right here in the program it sees a T1 M6. M6 means tool change to tool number 1. Remember in the library we typed in center drill? So it comes up here, change tool 1 to center drill. Notice here it says height offset of 3 right now. Well, eventually it's going to get down to this line where it says G43 H1, and that'll change to an H1. We did too much detail here. But I hit cycle start. Spindle starts, and we start moving over. You're going to want to look at the part, not the monitor at this point. But you should be able to, it did change to H1, so I know the height offset's been corrected for this. And I just set up my tool a little bit better here. And this should come down and drill. Right now, like see, I'm about a quarter of an inch on the Z coordinate, which is about a quarter of an inch above the fixture, which is good. I'm slowly increasing my feed. And because that's such a small hole, it isn't going to center drill very deep. That's it. That operation of center drilling is done. Center drilled apart. And use the brake here. Take this out. Tool number 2 goes in next. Looks good. Bring that down. We hit cycle start again. Again, if this is my second, third, fourth part, my 1000th part, I would crank that feed right up. On your first part, you just want to be a little bit on the cautious side. I can see in my code, while I adjust this, I can see in my code that I've used the G83, which is a drilling deep hole cycle. Notice the drill goes down and comes up, down and up. That's all programmed with one line of code. You can't feed it too slow to the point where the tool rubs rather than cuts. There's our hole drill. It didn't take long. Slip off of there. Now I'm going to go to tool number 3. Now I get real serious here in the end mill. Okay, let's cycle start. We're on tool number 3. Looks like we're starting with the hole. So the part is held in such a way that the cutter can get right in and mill the hole. That's another thing a setup person would do, is after he runs his first part, he'd keep notes on the first part. Like he might say that, setup person might say, we need to run the feed at 80% in this particular operation. Or the next one, maybe we can run it at 120%. And then he'll go back to the programmer, and the programmer will change the program so the operator doesn't have to sit there and change the dial the whole time he's running the part. I want to make sure the coolant stays in there. If you load that cutter up and the coolant doesn't get to it, chips can weld through the cutter and it stops cutting and the cutter breaks. We don't want that to happen. I'm just going to jump in front here and get the air hose. Now in industry, you'd have so much coolant shooting in there that those chips wouldn't even have a chance to accumulate. But here, I'm just going to blow them out of the way a little bit. I'm trying to also make it so you can see what's happening. You can see that. We just machined that hole, roughed it out, now we're going to go around for a finish pass. be a little tricky to do that on a manual mill. Just two hand wheels. You do it with a rotary table, but an offset motor again. There are a number of ways you can do it. But this allows you to do any complex shape. Yeah, just doing a finishing operation on that. I think the whole part only takes, I don't know, 3 or 4 minutes when you're at the right feed rate. Okay, then I should wrap it out of that hole. Right, I think it goes to the center of the hole, or pulls away a little bit. Wrap it up. No chips can get up inside there once that tool's out of there. Now it's important here to follow the setup sheet, because you're not going to take this tool out, you're going to use it again. But before you can use it, you have to install the clamps. And in my program, I've written, if we look at the screen here now, I've added in my program, so that the operator can see, add brass hole clamp and 632 screw, then run. Again, it's going to be tool 3. And in the setup sheet, you can see that for setup 1, we've done that. Now we're in setup 2. We're going to add that brass plug and that screw there. So before I can do that, I have to clean that part out thoroughly. It's very important. Machine tool will always do everything very clean. If you're machining something that's within 1/10,000th of an inch, you don't want a 20,000th thick chip underneath the part. Lightly brush this off, and then I'm going to take the air hose to it. Now there is a little burr here around this hole, and I anticipated that when I designed the fixture, and this plug is undercut to compensate for that burr, so we don't have to stop and deburr the part at this point. It's not much of a burr, but I put that plug in there. Screw that socket head's cap screw right in. Tighten it up. Now if I wanted to spend more time, and I was going to make millions of these parts, I could have come up with an even slicker way of doing this. Like an expanding mandrel that would pull it down from the bottom. But the number of parts that we're making, this gives you the idea of something you might see in industry. Another thing I'll show you is underneath this socket head cap screw, I've got a little brass washer. You want to think of these things because you could scrap the part if the screw scratches the part. So that little brass washer prevents that from happening. Go ahead and tighten that socket head cap screw. I think this would work without this, but I haven't tried it yet, so let's not this time. So we'll go ahead and make sure everything's tight. And we can run the part again. Run the program again from here. Cycle start. See, as this machines the part, it's going to be machining the material away where it's being clamped. The part's going to be just floating. So it's going to come in. All my clothes will look the way they do. It's going to come in and it's going to plunge in. Plunging in right here. Go around. It's always a good idea to leave a little material for when you plunge in for a finish pass, because when the tool plunges in, it can vibrate a little bit and leave a bad surface finish. Feed that up a little bit. There we go. That's another issue. See, if I feed it too slow, the chips are so thin that they don't break. They just get longer and longer in a big ball. So sometimes being cautious can actually cause more problems if you go too slow here. It'll be wet all day. You want to make sure that that coolant is able tool interface. And that ball of chips is giving us a little bit of trouble there. Another thing you have to do when you design a fixture, oftentimes you have to design it for coolant and chip flow, so it'll flow away from the part. There's a lot to fixture design. There's strength, the materials in there, a lot of kinematics. As it breaks out the end of the stock, you hear noise change a little bit. Comes right around the end. Screw's pretty close, but if it misses, it misses. You have to be a little concerned with chips. If you're coming real close to a fixture component and chips get sucked into there, that can cause the cutter to jump a little bit. The fixture. We're doing pretty good there. I think we probably even speed that up a little bit. A lot of times, what you're doing when you're cutting like this is you're listening. You're listening to the sound of that cut. I hear a nice wholesome chip being taken out of that. You hear squealing, oftentimes that means you're not feeding it fast enough because the cutter's rubbing instead of cutting. You hear sort of a dull, varying tone, which can mean that the chips are overloading the cutter. You may only have seconds to slow it down before it breaks. Keep that clean up. See the part is starting to form here, the shape. Go around once to rough it. You can see now that the part is separated, the actual component is separated from the stock that's being clamped. That's why we needed the plug and the screw. Come on, skip the LP down. As a setup person, I'm taking note of what my feed rate is in this first pass. I can make adjustments. But this is the finished pass. I have to make sure that I'm getting the required finish for the print. And what I want to do is I want to increase the feed rate right up to that point. We back off a little bit after that. We want to maximize efficiency, but we want to still be able to produce good parts for the required surface finish. Actually, for this part, the outer profile doesn't mate up with anything except air. The inner hole does mate up with something, so that's the finish on that's much more critical than the outer finish. Of course, we want it to look pretty in this case, so we're gonna not go too fast. Much of this fixture I made on the CNC machine too. In fact, almost all of it. You see that handle that was made on this CNC machine. Coming into the home stretch here. This part's almost done. Once the machine's set up, the bugs are worked out, you can just keep feeding stock into that all day long. Then it shifts from the setup person, who's a very skilled person, to an operator. Now the operator is somebody who may or may not be very skilled. They pretty much stand here all day, load stock, hit cycle start. And when they take that piece of stock out, they'll deburr it while the next piece is running. And they might just do that all day long. Thousands of parts a day, millions of parts a year. I filled in for operators before, it can be very boring. But I've also been a setup person. I find that very interesting because it's different every time. Do one setup, we make 1 or 2 parts, and then move on to another setup. We'll learn it all that way. You can see a lot of fixtures. Some places where you go to work, like Pratt Whitney and GE, they would have you go into the different departments, like the tool design department, fixture design department, programming. So you get to spend a little time in each of those departments. It makes you a better engineer. Starting to look like a valve connecting rod. Program is right. This should wrap it up, not down, and wrap it over. So the other thing you do as a programmer is you try to have at the end of the program, the part fixture come over somewhere where you can be a safe distance from the cutter and where you can load and unload the part ergonomically without having to bend way over, or if you're using wrenches or whatnot. So let's take a look at that part. Try not to get carried away with the air hose. Just gently. This could even be in the setup sheet, the operator sheet in some shops, that you blow off the handle because they don't want you to accidentally grab chips and hurt your hands. But pull things off a little bit here. And I'm going to go ahead and take the plug out. So here's the plug. Stuck for some reason. Nope, it's out here first. And we'll get the other screw. It says it's not the fastest setup that it could possibly be, but compared to spending a couple of classes making this part, spending maybe 5 minutes once you get set up, it's pretty good. So here's our part. Get plug it in there. Part spin machine, it does need a little bit of deburring. That's another sign of a good programmer, is the less deburring you have to do as the result of your operation. Sometimes just changing the direction of cut can change the difference between whether you have heavy burrs or not. Once at Pratt Whitney, we had an operation that was leaving a heavy burr, and the deburring department was spending hours deburring the parts. And all you had to do was change the side of the part the cutter started on, and it rolled the chip into the part instead of off the part, and it saved hours and hours of this nasty material that needed to be deburred. So there's our part. And you can see here the fixture. We'll go back to the fixture for a second. We still have to loosen this up. Now, some clever engineer can decide to make something out of these parts. What kind of parts here? So the operator would clean this off. Extremely important that this all be just crazy clean. Can't be any chips in there at all. And then the operator would load another piece of stock. Tighten it. Change the tool. Second start, while that part is running, deburr this part. Got all deburred, ready to go. That's using the CNC machine. This is a bracket I made. I made actually 6 of them. It's for a canoe rack that was on the top of my vehicle. And so I've designed the process and the fixture and everything for this. And this is showing you the fixture. And you can see here on the screen, we've also got a fixture represented here. And this fixture, you notice, doesn't have this pin in it. This fixture is used for 2 setups. First, we're going to machine this side. We go around the outer profile. This goes on, locates on those 2 pins. And you can see here that we've got a screw that goes down through the hole. And it holds the part while it machines around the outer profile. does that step, does a corner round, does the holes, and then that pin gets put in, and then we flip this piece over, and it locates on this surface. There's our 3, then our 2 up against these pins, and then 1 up against this pin. So 3 to 1, we've located it, we put the screw in there. Now it can take and machine this step, do this corner round over here. So let's just go ahead and see what that looks like. This is showing the fixture. I've got the stock transparent right now, just so you can see what the fixture looks like underneath. Change it to a solid. And the cutter comes in and it cuts around the profile. I'll speed this up a little bit more. So it gets all the way through to the depth. The noise you're hearing is it's actually machining into the fixture now, which I knew it would do. And then it machines that step. Now that radius in here needed to be a little tighter, so I'm switching to a smaller end mill and I'm cleaning up that radius. And now we're drilling these holes, which are drain holes for any rain that collects in the top of the screw holes we're going to have here. And then a corner rounding tool comes around and rounds the corners here, and it rounds the corners of the holes. And that operation is done. And next I'll show you the second setup where this is facing the other way. Okay, this shows the fixture with that 3rd pin put in. Again, we're going to locate the piece. We're going to flip the piece over now, locate it like this, and up against that pin, and put a screw in to hold it. So it's shown here on the screen, and I've got it in wireframe just so you can see through it for now. And when we cut this, we're just going to cut that step, and then corner around the other side, and the part is done. When I actually machine the part out in the shop and set things up, it's not uncommon to machine your first part out of something called machinable wax. This is just a special wax with a high melting point, and once you've machined it, you can measure them, check the dimensions to see if they're coming out right. So it allows you to make it, and if a tool goes the wrong way, hopefully you don't destroy the tool. It just plows through the wax. So machinable wax, that's something else for you to learn about.